Alrighty. Okay, so the first thing, like I said, we're going to just create a grid of points, do something similar to the example I showed you, where we're just going to create some curves that are responding to the distance between their point and a point in Rhino. So there's a couple ways you can create a grid of points. We can just start off going to the vector, grid. Let's just do a square grid. You don't have to mess with the plane. You could if you want to start exploring. You can change the size of it. One's pretty good. And then we can change how many we have in each direction. I'm going to just double click the screen and hit, let's do 10 less than 30. By doing that, that's just kind of setting our high and low values for this slider. So we have a 10 by 10 grid. If I want to make it larger, I can always just do that. So you can see it's outputting cells, which are just the curves. So that's what you're seeing, as well as points. So let's go ahead and just look at the point. So I'm just going to go over to geometry, select the point component. And here's a good, so this will be a good example of showing the data trees right off the bat. You know you've got branching data when you have this dashed line. That means, similar to what I showed before, the way these grids are set up is that it understands there's points going in an X direction and a Y direction. I believe it starts off in the X direction, so it says, okay, let's make a series of points that are 15 cells apart, and then they've got 15 cells in the Y direction, right? So that's why it's being branched out, because it says, okay, let's make that series, and then let's make that series. So that's why we've got branching data. So if I look at it, I can see here's my first data tree, here's my second. I can even show you how it looks like this. So that's what it means, like each one of those branches has a certain number of points correlated with it. If I flatten it, you'll see there's just one branch. Again, I'll show you what that actually means when it comes to data manipulation, because I know it's kind of abstract in that sense and in this sense. It's not until we start to give some object representation that it makes sense. So right now, like I said, I'm just going to keep it branched out for now. So the next thing we need to do is create our own point. So in Rhino, I'm just going to use the point tool and just place this point somewhere within my grid. You can even put it on the outside, it'll still work. So I just have my own Rhino point in here. Are you guys keeping up?
No.
No?
No.
I just have my point somewhere in here. You can just put it anywhere within your grid.
We need to get that other graph you just got rid of.
Yep, you just need literally your square grid and this point.
Oh, okay. No, now I'm up to speed.
Okay. So what we're going to do is, like I said, we're going to just create lines that are representing their distance from this point. So all these, like I said in the presentation, all these points have a distance to this point that we just created, right? Make sense? So the first thing we have to do is actually form that parameter. So this is where what the assignment asks for is creating that one transformative property, I guess. That should probably actually be a parameter. So we have to create that first parameter. In this case, it's going to be distance or closest point. So the way we need to do that is first reference this point into Grasshopper. So select your point, grab the point component, right-click it, and say set one point. Okay, everyone got that?
No, it is a point.
So just draw it in Rhino.
Oh, okay. No, I don't.
Okay, so I'll take my time with this.
Got it.
So the next thing we need to do, like I said, is find the distance between this point and all these points. There's a couple, because we're only using one point, we can really just use the distance component. So let's do that one first. So I'm just gonna double click my Grasshopper screen and type distance. And what I need to know is the distance between these points and this single point. So again, you have your grid of points here and your individual Rhino point. That's giving you a bunch of different distances. If I look at this, I can see all those different values. So we're going to use these distance values. So again, these are our parameters. We're going to use those parameters to give some form of representation. So this is what I was saying before. An easy way is to just do a curve length. So if I go over to curve, so I'll go to this curve tab, choose the primitive tab, and do line SDL. So it's near the top over here. So you can see it's asking for a line start point. So that's our grid of points. This is where we're gonna draw these lines from. It's asking for a direction. Z is fine for now. You can see that they all have their own, they all have the same distance because it's defaulted to, I think, 1. So how are we going to create this parametric visual? What's the,
Slider.
no, what's the parameter we just created? A distance between 2 points, right? This is giving us a distance. It's giving us a numeric value, right? Could we use that value to represent the height of these curves?
Yes.
Yeah, so that's the whole purpose of this. So I'm going to take my distance component and drag that into my length. And now you can see they all change heights based off of that distance. And you know what's even cooler? That again makes me kind of sad that this is oohing and awing you. Like we've worked on scripts so much more comprehensive, and look at what we have.
Yeah, put a point in Rhino.
So
this is amazing.
So here's what we're getting out. So let's actually even turn off these points. It's not too congested. So how do we show that this is responsive or reactive? We want these curves to react to the distance of this point. So how do we show that it's actually not a static graph? It's way simpler than you guys think. What? No, that's still another visual, but I want to show that this isn't a static. This is just showing one form. Could these lines change in height?
Yes.
How? Move the dot.
The first.
So I'm going to take my point in Rhino, I'm going to move it. Oh, and look at how it responds and reacts.
Okay, then.
So here's something like, you don't have to follow along with this, but here's something that's cool that you could do. You could actually start to kind of draw some kind of wacky undulating curve. So maybe this is a river going through the site. Something relative, right? I'm going to reference this curve. And again, I'm going to do the same thing of, let's say we want to indicate something that's moving within this river or this curve. I'm going to use the curve and use the point on curve. That way I can just kind of drag this point. So it's essentially, here's where the start of the curve is. Here's like halfway, and then here's the end. So if I can like move this slider, does that start to indicate something?
Yes.
Could I replace something else with this?
Yes.
What should I replace?
The point.
Which point?
The
This
one?
one?
Yeah, that one.
Yeah, so let's see what happens if I drag this over here. So right now they're all pretty far away. And now, let's make sure we can see everything. I'll turn this one off. So here's our particle. It's flowing down the river. It's getting closer. Wow. So this is how you can start to, like I said, create a reactive model. Like, this is pretty much as primitive as it can get. Like, it's, I mean, primitive in terms of the complexity of the script, but still being a very kind of powerful visual, right? We understand this direct relationship. So like, this is kind of weird. Like, this is where I'm saying there's sometimes where you need to change or reinterpolate the data. Right now, like, because these points are just really close, they have a small line, right? But then the ones that are further away have a longer line, right? That's just that linear interpolation of data. Does that make sense in all cases? Sometimes proximity, you want to show a higher value, right? So this one's actually really easy. We just have to simply invert that distance value. So if I just go to math, operations, actually let's do, what would be a good way for this? I should be able to just reverse this. Oh, here's the other, I mean, it's working. Yeah, never mind. So what we're gonna do is actually just, I should be able to right click on this and say reverse. So now all those values get flipped. So nope, that didn't work. So we don't want to reverse that. We actually, I think it's going to be, no. Let's go to sets. No, it's the same one. I was hoping there's a simpler one, but we can still do it pretty easily if I go to, okay, so all you have to do is take, the value. So we're going to do a simple division and divide 1 by that value. So that way, 1 divided, so like if you were to have a distance of 10 versus a distance of 1, 1 divided by 1 is 1, 1 divided by 10 is 0.10. So that's one way you can easily reverse that, it's going to drastically reduce that. But then we can even just use the multiplier. You guys don't have to follow along with this part. I'm just showing you how it's kind of a very primitive way of doing it. And then I can multiply it by 10 to return it to that value. So now you can see that all those points that are really close to this have that kind of value. Okay? So let's look at a couple other ways we can remap that value. So we have, again, a linear. What are some of those other forms of interpolation? How else can I interpolate that data? I showed you 4 different graphs. I showed you this linear one. I just showed you the nonlinear. Which one?
The shape one.
No, we're talking about how do you manipulate data.
Oh,
Remap it, right? So instead of, there's all sorts of cool ways we can remap that. So let's do the first one. So I'm going to stay in my math component. So this is again where you guys can follow along again. I'm going to go to domain, and I'm going to go down here and say remap numbers. I'm going to drag. So what this is asking for is your value to remap, or in this case, values. So these are all our distances. Those are the values we're changing. We need to find their source domain. So essentially what their high and their low values are. So I'm going to stay with domain. I'm going to choose bounds. You can even see in the icon, it says minimum and max. So I'm going to drag that into there, drag this into there. Because this isn't exactly doing what I thought it was, let's go ahead and flatten all this because it'll make life easier. So I'm going to go all the way from the start here of points and say flatten from our square grid. So now we can see we have all solid lines. That means all the data is being treated equally. So this is how we can remap it. So we need to create a new domain. So this is where I was saying, oops, in this exercise, so instead of that 1 being a 1, now that 1 can be a 7, and that 10 can be a 9. Okay, and then everything in between will change. So let's construct a domain. So again, domain, construct domain. And now we get to assign what those limits are. So what do you think the closest points value should be? Give you guys that freedom to say. What do you, how tall should the closest curves be?
1.
Let's go with a high number. Because right now they're already essentially representing 1.
Oh, 10.
Okay, let's go with 10. What about our furthest values?
100?
Now let's have those be, so like I would say, kind of like what we're trying to go for before, we want our closer values to read higher than our further values.
Oh. 1.
We've already kind of done a simple 1 to 10 ratio.
5.
Okay, let's do 5. I told you guys you can choose what I'm ultimately going to. So let's just see what this means real quick. So I'm going to just pull out this panel. Again, you don't have to follow along. You can see though the distance between our closest point and our furthest point is 0.4 is our closest, and our furthest is 13. So that's just how they're being represented. So that furthest point, which looks like it's over there, is 13 feet tall. This closest one in here is 0.4 feet tall. Make sense? And then there's all those other values in between. So what this does is it says, okay, that closest one, so let's just copy and paste this. So now we've inverted that, right? So that closest point, which is 0.4, is now reading as 10. That furthest one of 13, so that furthest one is going to read as 5. And then all those values in between that domain are going to just shrink between these two values. Does that make sense?
Yes.
So if the next one was, if this was reading as a 1 and now it's reading as a 10, what would a 2 read as?
Like a 9.5.
Let's say, so if this was a 1 and this was a 10,
Oh.
and we remapped it to be, okay, this is a 10 and this is a 1.
Yeah, 9.
It'd be a 9, right? And then a 3 would equal an 8, a 4 would equal a 7. So you're really just kind of flipping those around. In this case, obviously the data is much more intricate than that, but it does the same thing. So now with that, so we've remapped that and we've created sliders. So if we want to say the minimum value is higher, we can always do that as well. So now we get our remapped value. That's what's going to go into the length of our curves now. So let's drag that. So now you have this kind of very smooth looking surface or series of points. Same thing, I can drag this and it'll all respond nicely to it. Let's say we wanted to show a more drastic change. So right now, the range between a 10 and a 5 isn't that great, right? There's really not that many values in between. So if I want these to read smaller, I can just drag that down. If I want this to be larger, I can drag it up to like a 20, just so we can start to kind of exaggerate that data. Okay? Makes sense so far?
Yeah.
In terms of remapping the data?
Yeah.
Again, there's some times where you want to keep it, there's some times where you don't. For example, one way you might want to remap data where you're not actually manipulating it or reducing its integrity, but if I were to use these same values for scaling something, that would be much more dramatic because scale works on a 1 equals its original scale, right? And then 0.5 is half of its scale. So if I were to like make it 13 times its size, that might not be relevant versus just shrinking it, right? Okay, so you can start to see we're adding a little more complexity to it.
Repeat that last part?
So it makes sense to have values that go up to 20 for this, right? Just to visually see it better. But when it comes to scaling something, if I were to scale, let's save that for later. I'll come back to that. So let's just show the last form of remapping data. What was that? What's the last way I can remap data? Interpolate or
Distance apart.
which is
The fluctuation.
the graph mapper. So I can use a graph to manipulate this data too, so that maybe, again, the closer it is, the taller it is, but then it recedes, but then it comes back to being tall. So let's do that as our last part. I'm going to delete my remap, and I'm going to delete my bounds. I'm going to go over to parameter. I'm going to choose input. And I'm going to choose graph mapper. So what this needs is, I can actually delete the bounds too. So I just have my distance values. Or, sorry, let's keep the bounds just for clarity's sake, just so I know what these values are. Actually, for this, it's easier if you do remap them just to a simple 1 to 0 value. So I'm just going to undo that back to there. And I'm just going to say this is 1. So the closer ones are going to read as a 1, or no, let's just delete this, and it'll be defaulted to 0 to 1. So you can see the closest ones have 0 length, the furthest ones have 1. That's fine for the graph mapper. So I'm going to go to primitive, input, graph mapper. So I'm going to take these remapped values and drag them into here. And now I'm going to right click on it, say graph type, and I'm just going to choose assign for now. So I'm going to go near the bottom and I'll see this curve. So the first thing I want to do, this isn't going to change a whole lot, so I'm going to double click inside of it. This reads a lot like how we changed the domains of our values. Our 0 to 1 is something we don't want to change because that's what this remapper did. But we do want to change our y values, so that way the y values represent the height of our curves. So we don't want it to read as being between 0 and 1. We want to show a little bit of a higher value. So in this case, so you have 0 to 1 going across this graph, right? I want it actually to read now. So we still want the 0 to be 0, but maybe we even want to jump that up to 1. So the minimum value is 1. And then we want to do the max value to be, I don't know, 15. So assign that a value. And then the last thing we want to do, because again, we want the closer to read as a high value and the further one to read as a low value, I'm going to click this circle down here and drag it up. Then I'm going to click this one over here and drag it down. So we just have this kind of gentle S curve. I'm going to hit OK. And now I'm going to drag this into my values. And so now you can actually start to see how it kind of has this more subtle S curve. If I want to change it up, I can even drag this curve. So this is where it kind of goes back to, so this point, which is about like 0.75 away, that gets mapped as 1, but then it starts to return up to a higher value. Like I said, there's very little or rare occasions where you want to show something like this, but it is something to be aware of. So does this make sense? Like if I look at this like this, you can almost see how that length is relating to this graph. So these ones that are closest are this peak, then about 3/4 of the way from that, they get to the lowest, but then they start to return back to their highest. Yeah.
Could you add more points to it to see how it would look?
Yep. So more, what do you mean more
Like the
points?
bar that you had up there, you could look at 30, your first bar.
This grid?
Yeah.
Sure.
So
So that's kind of
it's the
crazy.
same look, it just kind of spreads it out more, but it's still going to give you that same shape.
Yep. Okay, so that's the last way we want to show how you can manipulate data. Manipulate data. So let's get back to the rest of the assignment. So it's asking for 3 different transformations, right? We've shown how many? What?
Again?
How many transformations have we shown so far?
3.
Well, how many is this showing right now?
This one's showing you.
So it's only showing 1. I'm only seeing a change in height. What are some other ways we can,
Distance apart.
how else can we visualize this?
Color.
Color, shape, size, all sorts of crazy stuff. So that's what we're gonna do now. So maybe I'll keep this graph mapper. So like I said, another way we can do is actually the color as well. But before that, let's actually look, what happens if we want to show multiple points within this instead of just the single one? So That way you don't feel like, so you could just do 1 point or you could show multiple and we'll see what that does. So what I'm gonna do is I have this single point shown in there. I'm gonna draw 2 more. And we're gonna still just stick with our closest point parameter. So just draw 3 somewhere in there. And now you're gonna reference those 3 points into Grasshopper again. So I got my 3 points. I got a point component. Say set multiple points. So you can see it's not doing anything. It's really just responding to this point so far. Can you all see that? Like you would think like, oh, what about these points? Why aren't they? You'd think those ones are pretty close. Why isn't that? So this is only working off of 1 point. It's just going to read that first list or that first list item. So instead of using the distance, we're going to use the closest point component. So now I'm going to go over to vector, choose point, and then select closest point, not closest points, closest point. And it's really asking for the same thing. It just is going to operate a little bit different. So it says point to search from. That's our grid of points. And then it's asking for our cloud as a list. So cloud of points to search. So I'm going to drag that one into there. I'm going to get rid of this distance. So again, you have your grid of points that you created from that component going into this first one. And then you have your 3 Rhino points that are there. So there's those 3 points. And here's a cool way again in which you can just visualize this. This isn't part of it. But if I just draw a curve, this kind of just shows you how this is functioning. I'm just going to draw a line between my grid of points. So let's see those. And these points. So what it's going to do is it's going to determine, in this case, are these points closest to this point or are they closest to this point? And so when I draw this, you'll see how it starts to kind of divide it out. So it's along this kind of sector where some of these points are closest to this one versus that one or that one. So does that make sense? So like it's essentially they're just subdividing those points into their respective proximities. That's just the line component. You don't have to worry about this. I'm just showing you how this is actually operating or working. So that way, it does the same thing. It's giving you a distance. So just like that other component where we measure distance, this is just a little bit more advanced. I'm going to drag my distance into here. Then I'm going to drag my distance to my bounds. And now you can see I have these 3 peaks and then all those other values in between. Yeah, Deacon. So it's subdividing it. So if here's your 2 Rhino points, and then there's a point somewhere in between them, right? It's deciding, is this point closer to this one or closer to that one? And it's just determining, okay, whichever one it's closest to, let's just pair it with that point. Does that make sense? So let's look at this again. So it makes sense that these points around here are closer to that one than that one, right? It's not until you start to get into that middle area where it's determining, okay, which is this point closest to here or to that one? This line is just showing, okay, that one's closer to this. So it's just determining out of all these grid of points, which of these other 3 points is it closest to? And it's just drawing a line to show which ones are being connected. Okay, does that make sense to everyone?
Yeah.
Okay. So that's why you can see now there's 3 of these peaks, and then there's all these middle values in between. Okay, so we said this is only showing, again, one transformation, right? It's just showing height. What are some other things we can show? Color, right? So what's great about this is we can use a lot of this value and just plug it in to another component. So I'm going to use our gradient tool to figure that out. It's very similar to this remap, but now it's just doing color instead of values. So again, I'm being asked for my series of values. So that's going to be these ones. It needs the high value and the low value of those distances. Let's actually use this one since we've remapped it. So let's take out of our graph mapper, because this is how we've manipulated the data, right? So we can't use previous versions of that data. We have to use however we've interpolated it, right? So we need to find the lower value and the higher value. So we're going to use our bounds tool. So now we can see our low again is 1 and 15. That's pretty obvious since that's what we assigned with our graph mapper, 1 and 15. But now we need to deconstruct it to get those individual values. So now, again, we're inputting 1 and 15 as a whole, as a domain. And now what this does is it deconstructs it. So we now have an individual output of 1 and an individual output of 15, right? Makes sense where you're just separating that data. And now that goes into this lower one. This one goes into the higher one. So now what this is doing is saying, okay, whatever values are 1, this is list 0, are going to be this red. And then the values that are 15 are going to be this orange color. So according to this visual, what color are the tall curves going to be then?
Light yellow.
They're going to be that orange, right? Because they're the further one. And then I guess that kind of looked, yeah, the projector's the one. But then the further ones are going to be this dark red, right? Or they're technically not further, they're the shorter ones. So now all we have to do is take our curves, go to display, preview, custom preview. I'm going to turn off this line component, drag it into there. So this just defaults it to like a pink, which is weird. But now I'm going to drag my color slide or my gradient tool, and now you can see how that works.
How would you invert that color?
So that's pretty simple. All you have to do is you could either change those values or I could just crisscross these.
Oh, you can do that?
So now it means our 1 value means the orange, or our longer value means the height, right? Obviously, I can change the presets to read something kind of what we're more familiar with, looking like. So yeah, there's your second transformation. Everyone understanding it?
Yes.
Getting it?
Mine doesn't look smooth.
Might have to do with, yeah.
Well, from what I can see, it's curve.
Are you using the graph mapper?
Yeah.
We can take a look at that.
It's just like yours looks like perfectly tight, and mine is like flat.
Gotcha. So we can play around just to make sure. Again, how do we show that this is reactive or responsive?
Sure. What do you ask? Oh, put a line through it.
We could put a line through it, or I can just take one of these points and move it, right? So this, again, just showing its flexibility. So there you go. So again, that's just something when you're starting to show your iterations that you show that it's actually changing based on your data. Yes, Danny.
What if you move the point outside of the grid, but it's still pretty close? Does it still read it?
Yeah, it'll still read it as a distance. It's just gonna read it as being much further away.
Oh, okay.
Obviously, if you read it further away, it's almost going to be considered non-effective.
Okay, so it doesn't have to be inside the grid.
No. So you could almost think of that when it comes to analysis, like, is that point influencing this information? If it's too far away, then probably not. That kind of gives you some form of analysis of influence, which is kind of cool. Okay, so what's one last transformation we can do?
Shape.
Shape, right? Oh, you guys wanted to pick a complicated one, okay. So because we need to show like how the shape transforms, right? So what we're going to do, actually, let's use our polygon tool. So we're going to go to our curve tab, choose primitive, and do polygon. We need to say where it's locating. So it's asking for a plane. In this case, it's the same as a point. So I'm going to drag my point from my grid into there. So now you can see they're all there. They're just really large. There's your radius, so that's the size of it. So let's just use a number slider to give us a value. This is good to know because maybe we want to add a fourth value. So we can actually change even the size of these polygons as they get closer or further away too. So now let's just give them a decent size. They aren't overlapping, but they're fairly close. Like I said, we could actually change the scale so the further they get small, and then the closer they get larger. That's what's the value of that. So like I said, but you guys want to choose the shape, right? So what should the shape look like when it's really close to the points?
Octagon.
So you want it to have 8 points.
Yes.
Okay. And then what should it look like when it gets further away?
Square.
Circle would be tough. I mean, you could just add like 100 points essentially. But there won't be a lot of change between like an octagon because it's already like from distance almost looks like a circle. It'd be easier from like a triangle to a circle. So octagon to a square, okay. So again, what data are we gonna base this off of? What have we been basing everything off of so far? The distance, right? So what is our most up-to-date or recent interpolation of that data? Which, I don't know what there is. Or the graph mapper, so this one. This is ultimately our newest form of our distance because we've remapped them and we've graphed them. So again, so this goes back to where we need to kind of change that. So if I were to just input these values, these are basing it off of 1 and 15, right? There's no such thing as a polygon with 1 point or one segment. And obviously 15 isn't going to give us an octagon, right? So this is one of those cases where you have to actually manipulate that data in order to fulfill that need, right? So we're going to say, instead of it being 15, it's going to be 8. And instead of 1, it's going to be what?
4.
That's right, you picked a square, right?
Yeah.
So yeah, so we need 8 segments for our octagon, and we need 4 segments for our square. Obviously, we're going to be able to change that if we want to change the shape. But that's how we do that. So this, again, we're going to remap these values. So I'm going to go to Math, Remap Numbers. So I have my source. So again, I can use the same bounds component here. So I'm still looking at a range from 1 to 15. So what's this new domain we have to create? What are the values for this domain?
8, 4.
8 to 4. So again, this is important to know where we place the 8 and what we place the 4. So what do you want the shapes look like that are closest? An octagon? Okay. So which value is that going to be?
8.
So, right. So 1 is a distance of, no, actually, so 1 means it's far away. 15 means it's close.
Right.
So notice the order of this. It goes 1 to 15. So this is the start of the domain. This is the end of the domain.
Oh, it's flipping it somewhere else.
Yeah, exactly. So we need that high value or that close. And technically, in this case, the close value is going to be what?
B.
It's going to be B, right? So that's where we give it an 8. And so what is the A domain going to mean?
The octagon?
The 8 is the octagon, right?
Yeah.
So what is the start of?
48. Oh, that's 4.
That's going to be 4. Yeah, you guys are getting it. So now we have our range from 6 to 4. Obviously, like this is going to even giving you like these decimal forms, which aren't going to be a shape, right? But when it comes into these segments, it rounds those values up. If it's 4.5, it becomes 5. If it's 4.3, it stays a 4. So you don't have to worry about that. I don't think for this, sometimes you can just do it anyway, so it looks like it worked. So now you can see these further ones are my square, my close ones are my octagon. Pretty cool.
Can you apply it to the height of the lines?
We sure can, Daniel. So let's do that. Let's say we want to have these extruded shapes that are those colors and those heights. Wow. So what we're going to do, instead of using a line now, we're using a shape, right? You okay, DK? So how do we do that? How do we create a shape instead of a curve? This is even just like Rhino talk.
You connect the polygon to the line.
You can do it that way, or, I mean, what's informing the line? Distance or height.
How close it is to the
But what data is feeding that? What?
point.
Well, the points, but where in the script am I informing the height of these curves?
The bar graph.
Yeah, this bad boy right there. So that's what's feeding the length for these curves, right? So that's the same value if I were to do what to these curves? How do I make these curves a shape? Extrude them, right? So I'm going to go to Surface, Freeform, and look at this. We have Extrude. So it's asking for the base curve. So which one's that? No.
I'm sorry, the one on the bottom.
Yeah, the one where I dragged it. So we're going to drag our polygon curve into our base. And now let's just, yeah, we can keep this here. And now we need to know a couple things. So direction. So what direction do we want these to extrude? Up. So in mathematical terms, Z. And so it's just going to default it to 1. So that's where you can see they've defaulted. So, but we need them to be relative to our distance, right? So which one goes into this one again?
The bar graph.
The bar graph or our graph. Yeah. And there we go.
But now how would you apply the color to it?
Just you wait, Daniel.
Alright.
So same thing. So we gave the curves that color, right? So what are we assigning to that color now?
Polygon.
The polygon, right? That extruded piece. Let's turn that off. And what?
Whoa.
So now we got
Why is there a hole?
red hexagons and green squares.
Why is there a hole?
So these aren't capped, which is fine because then we can just go to surface, cap holes. We'll turn this off because it's really just creating a solid. It's starting to lag because it's, like you can see, it's starting to create 3 values that it's forming. And again, it's going to lag a little bit, but I'm just going to drag these. Come on. There you go. I know, right? Let's see if, I don't think it's going to work for this. Well, I can change the color. Oh, I can even make it opaque. So let's give it some value. So that's pretty rad.
Gnarly.
So maybe even this one is a little. So what, like this again kind of goes into the representation part of this. So like even the yellow has a little bit of opaqueness to it. So unfortunately at surfaces, they don't read that great. But if I were to actually do, instead of it being a B-rep, if I were to make this into a mesh by going to mesh, mesh to B-rep, turn that off, drag that into there. Now it'll kind of get rid of all those edges to the shapes and it'll read a little bit clearer. So that's pretty cool.
Can you change that direction?
I don't know, can I?
Well, I know you can, but
Yeah, sure.
hopefully you can show it.
Is there, so like here's something too. Let's just turn off this grid in Rhino so we can see a little bit better. Okay, so what's great, like Karina didn't seem pleased that we're only doing a square. Maybe we want to give it 3 sides, so let's actually just give it 3. Now we'll see that our lowest values turn into a triangle and now square, pentagon, all the way up to, obviously if we add like, I don't know, let's be daring. I'm sure if I jump it up to 20, that'll be enough. Cool down, fam. Yeah, now it's looking like a circle. So you go from like a triangle to a circle. You can even see if I look in the top view, it almost looks like a cool little height field or graph. I know, mind blowing, right? Is there something else we might want to add to this? Boring.
Oh, wow.
They all look like they're the same size, right? Yeah, let's change the size. Yeah. So what we can do, so we can see that the current, let's see, so here's our size. We kind of did that at 0.37. What we can do now is actually even remap this value so it's not just one single radius for these polygons, right? Yeah, but so like 0.37, those are already almost getting pretty close together, right? this remap is going from 1 to 15. We're going to have to remap it, right? So, again, we're going to, let's just, yeah, there's a lot of remapping for this. But this, again, where I'm showing you examples where, like, you have to remap values. You can't use the same value out of this. We've almost remapped it every single time. So let's remap it again. So I'm going to drag these values into here. I'll use the same bound. And so we can see that 0.37 is already pretty close. Let's see if we can get it up to like 0.5. See if, like, we just don't want them to start overlapping. So that's like pretty much right on, right? Let's just say like 0.45. So again, we're going to reconstruct our domain for this. So again, it's 1 to 15. So 1 being the furthest, 15 being the closest. What do we want A to be?
A is going to be 20. 0.2.
0.2. Let's go with 0.2. Let's do 0.1 just to really kind of showcase it. Again, by doing sliders, you can always adjust these. And then for our B value, what should that be?
0.45.
I'll buy that. And now we can drag these values into our radius. What?
What?
That looks cool. Go 3D? Did I hear 3D?
Yeah. That's what.
That's pretty cool.
Can you look at the values?
What?
Look at the values?
Yeah, it's just gonna,
Just because it was moving in the circle, the one with the triangles.
so,
Not on the.
I see what you, sure. Let's lock this just so nothing actually changes, because else it's just gonna have to like reprocess it all. Say that again? Oh, so you want the height themselves to change?
That's cool. So like it's green lower at the bottom and it gets red as the higher you.
We sure can,
Bruno.
Bruno. Okay. So before we do that, you can already see. So how many transformations have we made?
4.
4, right? That's probably going to get you an A because I only asked for 3. You go for 5, you can start to rotate. Oh yeah. This is only just showing like closest point, right? We haven't even like touched slope or height. I mean, this one could start to actually do height or elevation, but yeah, let's do what Bruno suggested. So what we're going to do, it gets a little bit trickier because we're essentially having to create segments of each one of these. So I'm going to remove some of these. So instead of it being a bunch of different shapes, let's just do one shape to make life easier. Someone give me a shape.
Star.
I hear triangle.
Really? A star?
Let's do triangle.
Star. Yeah,
He said a shape.
You started.
I'd have to individually
What about
create.
heart? Can you do a heart?
No.
Wow.
Too much?
Come on, Susie. So we're just going to do our triangle. So as you can see, and we'll, yeah, we can do it all the same. We can as well. I don't like that they're getting small. Let's return this back to the original. So there's your triangles. So yeah, like Bruno said, let's actually do it as their height. So what? Yeah.
Please. It's better. Come on.
Yeah, what can't I do with them? Okay. No, not really. Okay, so the way we do this This is my favorite part is when you guys ask me for me to do stuff and I just go bam. So how does so you want the height or the color to change as the height goes, right? So again, what type of data is that?
That is,
So if I want the bottom of it to read one color and the top of it to read another color, that's height, right? So what's the actual data? So if we were to think of we have a 3D space, right? So what is that actual data?
Z.
Z data. So we need those Z coordinates to figure out its relative height, right? So let's do it this way. So it's kind of hard to do it, but but at the same time, it's kind of easy because we already have a mesh. We kind of covered this in the stormwater class. So what we can do is I'm just going to let's just delete these for now. Ooh, no, not that one. We just don't want to connect it. Okay. So the way we're going to find the height of our mesh is we have to, again, deconstruct it to look at it for all its point value. So I'm going to go to mesh, deconstruct mesh, and as you can see, there's all these different points that make up those meshes. If I were to change this, it might give us a little bit more dense information. I'm a little worried because there's not a lot of points in between. It's really just the points at the top of the geometry and the points at the bottom. It might work, it might not, we'll see. So, but like I said, we have our vertices or our points, right? So we can go to vector, deconstruct these points, and now here we have our Z values. Again, we're using our Z values to determine our color range. And then we also need the high and those low limits. So again, we're going to go to math, bounds for the domain, deconstruct that domain. And so,
Why are you using that instead of Remap?
because we don't need to. It's just its relative height, right? So the start is going to be a faint green. And the end is going to be this opaque red. And let's see what it looks like. And then nope, it doesn't like that. Let's see. Yeah, it doesn't like that at all. Let's see what happens if we flatten this. Yeah, it's not a fan of that technique. So another way we can do it. So you have to essentially, it's really going to be a bunch of segments instead of one smooth color, unfortunately. That's just the way the color arrangement works. So, oh, that's probably why, because I didn't reconstruct this. So let's lock this down. So like I deconstructed it, but I needed to reconstruct it. So let's, again, connect my vertices back, my faces back, and now my colors. That makes sense because like I have a solid line and a dashed line. Usually if that happens, that's not going to be good. There we go.
There you go.
There you go, Bruno.
It's not applying it to the light, though. It's just,
Yeah, it's really kind of, it's even interpolating that because it would be technically, and that's why I said because there's only those certain points, it's really only registering, because when you see this, there's only the top point, so that's your red, and then there's your bottom point, which is green. There's nothing in the middle to tell it what those values are. So that's why I was saying it's actually easier. You could do it with curves. Trying to think of a good way to divide these surfaces.
so are we making the Z value more?
No. What kind of question is that?
This is the first time I see grass hopper.
I know, I'm just teasing.
Second, that's not really water.
I can do it with a much more simpler one just because I don't want to crash this, but so let's just do a circle for now. And we could probably get away with the same radius. I don't know if I really care to give it that much, but oh well. Yeah, oh, you'll see. So again, we're just going to deal with these circles. It's going to look the same as what we did before. I mean, that kind of gets it, but you can still see, like, in reality, these colors would stay at the same level, right? So that's why, like, it's because it's still running off this mesh component, which is what we do not want it to do. So again, we're going to take these, and essentially, like, the highest ones are going to be red, and the next segment's going to be the next color, and so forth and so on, right? So what we need to do is actually split these. So I'm going to do transform or intersect mathematical contour. We're going to contour these and essentially just slice them like really close together as long as my computer can handle it. So distance, so let's try like 0.5. And then maybe we don't cap them. So you can see like how many times they're going to get sliced. So that's just the resolution of the data. So I'm not going to cap it just because that's one less thing we need to know. But this kind of touches on the other topic of doing height relations. Okay, so what we're going to do is then split brep and let this process everything.
What's that does? You can scroll your file.
It doesn't help that it overheats the laptop and performance. That's pretty damaging.
Yeah, that's about it, right?
Considering everything's integrated, so like if you overheat one component, you have to replace like the entire computer.
It's still running.
Oh yeah.
Those fans went on now.
How long have you had your laptop?
Just over a year now. Every like 4 to 5 years. Yeah. And it's not because like for performance, it's purely because it's just no longer really functioning. So like I really kind of run them to the ground. Like the other one, like it can't even like hold a battery charge anymore. So I have to like keep it completely plugged in. And even that, sometimes it doesn't register the charger, and so it'll just like shut off. I'm like, yeah.
And then even if I have it plugged in, like it gets hot and I turn it off.
Oh, really?
But it was,
So all this is coming out of the recording, right?
I guess so.
Not all your 50 followers, none of
I know, right?
Susie's laptop. So if I do this, I should go to lunch while it does this?
You might have to. Come on, baby.
So I put it next to the AC. Just to make sure they don't
Yeah.
put a fan on.
I would just suggest don't do this technique.
Okay.
It's easier if I can show you can still do this height field technique. Obviously, we did it in the stormwater class. If it's with a solid surface, but when you're just processing this much geometry or information, it's a little harsh on it.
Or could you sort of break it and then apply that, but kind of height them, actually?
Yeah.
Shape of it?
Where did it do?
No, that's a good.
Going to Alabama.
Nice. That's fine.
Are you getting married at the end of school?
That's something you want to record.
Yeah, I don't know if I want this.
Just not even.
It's in January, yeah. Beginning of January, before school starts.
We're out of classes, so.
Yeah.
So can we come? Smart.
No.
That's one of your favorite school? What do you guys?
No, out of my students, you guys could get first dibs, but not for the price per plate. No.
I'll bring my own lunch.
No, even for going.
Pull out a sandwich. Where'd you get that? Farmer Hammond's? There's a pepper.
I'll hire some bodyguards just in case you guys decide to show up.
Oh, so you'd rather pay the.
I have all your mugshots from the wayfinding document anyway now, so
I wasn't in that one.
I can still take a photo and just.
That one, oh, I wasn't in that one.
At the
Oh,
bottom.
yeah. Oh.
Yeah, we definitely have to trim this part of the video. Nope, we're committed. We have to follow through.
He said he could do it, and it was in the recording, so now he has to do it.
It's true. Then I lose followers.
Yeah.
What's up? Like 90%.
I'm sure you're mutual.
I was gonna get it, but it's not.
That I went to the architecture part.
Was I really?
And I saw you last year, and I was like, hey, this is doing.
The CFA 100 class? I like that was such a crazy class because it's like every 3 weeks it's like a new batch of students, and it's just like I can't remember anyone, so I apologize for not recognizing. I remember I actually this says a lot, but I do remember Jack being in that class. Him, right? I remember him, and I think I also remember Eduardo. He's graduated last year. I remember he was in that too. Yeah,
Jack was in that?
that was when was that? I taught that. Karina, what year was that?
What class was this?
Yeah, that was like when I first started out.
Yeah, he was teaching like the architecture.
Yeah. So you saw the William White video then. So there you go. Oh, thanks.
Hey, what other classes were you teaching when you first started Stonewall? Because I remember you. Back in 2013, I remember you.
Really?
I just seen you in the hallway.
Oh.
Like the class that I was supposed to measure with, they had you.
Yeah, I started fall 2013.
It was Diego and Grant and all them.
Yeah.
That's the only class you were teaching, though, right?
I also taught 280, the foundation studio.
Oh, okay.
I taught that in the CFA as my first class. Yeah.
Oh, that's right. I started doing that too. We used to have like specific.
But they didn't require it. It's not required in your classes, is it? Because I don't like remember anyone. Hmm.
I think most of them were to start with. Oh, yeah, no, I think the ones that they started here.
I was like, hey,
Oh,
it's still like fresh in my mind.
This goes, right?
gotcha. Ah.
Right, that makes sense.
Yeah, I can. And they didn't like Karen. I don't think I had one student came up like, yeah, I think I'm gonna study architecture now. You can't even like make that decision in like 3 weeks worth of content.
Don't they already kind of have an idea what they want to do? That's why they're taking that intro class?
Yeah, for the most part, but not always. If you're lucky, you do.
I would say all the cases in the
Yeah. She was want to do it. Like, hey, you're my 180.
No, otherwise, no. No, it has to do with it.
The part where I asked him last.
Hey, check if your process is running full speed right now, it probably is.
Yeah, probably.
Probably like 100% running right now.
So, okay, so this is obviously just the example for doing closest point. The other examples that you could do are doing slope or angle as well as the height. So this is like what we're trying to accomplish here. It kind of takes care of that height parameter. Slope angle, I mean, a lot of that comes from like our stormwater class. Let's try one more thing. Well, if I hold escape, maybe it'll, sometimes if you hold escape, it'll like stop that function, but it's too late.
Usually when you do the task manager, sometimes it just fixes it without actually.
That's true. Yeah, see, my memory's only at like 26%. Just because the data itself. See, Rhino's not actually frozen or not responding. It's just, it should be the same thing. Yeah, I'm only using half my memory and CPUs. Wonder if I can change the performance settings in here.
and then my computer shut off.
And what happened?
And then I had to redo it. It's because I had a lot of high poly trees in it. It's just like, well, push it to the limit. That's what happened. It just shut off and nobody could do it. But I had like a lot.
It used to happen to me.
I had like a long grid, and then 50, like, with a bunch of poly trees. Trying to render it.
I used to do it to my other one. My other laptop wasn't like also.
No, there's this one.
Let's try it. There we go. High performance.
There's a lot of polygon. Can I render it? Shadows and all? I mean, I knew it wasn't gonna matter. I just wanted to see how much I just wanted to see what it would do. Yeah, my CPU was up.
Okay, so how many of you think you have a firm grasp of what it means with the closest point or distance and how that can be, how the data between one or multiple points and a grid of points can set a form of parameters in which you can manipulate?
Yes.
So this can apply in ways of, well, you have to ask the hard questions.
That's what I don't like. I didn't know this,
So it can depend on a lot of things. So the closest point, so
but. So we can like when we're making it,
yeah.
we can make something.
No, I get it. So you can think of it, so, I mean, let's just start to ask those questions. Like, how might this relate to stormwater? So,
So if it's like, not that curve that we did, it could be like has the stream and the way you want to.
Is it like gold?
probably not that. So let's think with stormwater, like, you have, for the most part, you should always have some type of outlet device, whether it's a pipe that goes underground or some type of check dam or whatnot. You can use that outlet as a point, right? So that could be your closest point. So you could create it in a way that maybe, so let's say you design a detention basin around that outlet point, and you want to create a series of modules within your detention pond. You can tell it to say, okay, I have my modules that are, so let's just think of it this way. Like we can even just draw that out. Let's get a better pen. Thank you, Fatima, for asking the brave questions. Okay. So you have your outlet, right? So this is like your closest point parameter. Let's say we divide this into a series of modules. So this is just kind of a figurative grid. And I'm gonna slice them this way. So you have all these different modules that you take into your detention. Each one of those has a point within them, right? Like a center point. Right? So you have this point within a relation or distance with all those other points. How could you imagine your module looking like that are really close to this point versus further away? What might you want to do to that? This goes into like, how are you going to transform this grid or these modules. Let's think of it like water's collecting in this area. What do you want that water to do? Huh? Into the base, like, I guess in terms of performative aspects, what are those kind of natural conditions we want to have? What do we want water to do? Think about the natural hydrologic cycle. Do you want it to evaporate? Maybe. We want it to go into the ground, right? So we want it to infiltrate. So what if we would imagine these as all some type of solid surface? So around the edges, maybe it makes sense. But then maybe, so let's think of these as some kind of concrete paver. But then maybe we make large cutouts or hollow out those pavers when it gets really close to that point. So these are like large cutouts, so in detail, they just have like this thin edge to it, and then you have like grass growing out of it, right? So that's what that detail of these could look like, but then as it gets further away, they start to close up. And now it's a solid paver. That could be one. What would happen, like, so now we have these solid pavers. Is that something good to have?
Yes.
Okay. So let's say it's a good thing to have. Like, what can we do with solid pavers? We could start to actually add some program to it. So let's say we have a section of this. So again, we have our, maybe the pavers that are again closest to this point start to run flush with the grade, right? But then as they get further away, so let's say they're still staying tangent, but then slowly they start to maybe start to kind of plane out, and maybe they extrude. Further, so people can like sit down and they can start to serve like a program. So now not only are they becoming solid, then they start to kind of break away from that existing grade to create something more architectural in terms of program. So these are some of those things that you can start to think about the relevancy for the closest point. There's obviously, this is again showing like two different transformations. You're changing this kind of cutout in the paver, and then you're changing its orientation. You can obviously change all sorts of other things. You can manipulate them in different ways, but that's one example. Is that answer? So now you guys can already have an example of how to do a cool drainage basin. What? Are you not? You aren't going to do that in stormwater class? Yeah. So that's an example with closest point. This is another thing, like, so what I was also getting at with this is, what else can we analyze from this detention basin? So this is analyzing.
How much water did you say?
Nah. What, in terms of its geometry or its form, what else can we, what other parameter can we extract from this? Slope, right? So if we were to look at these again as like very kind of rigidly as these planes, they're all pointing in different directions. These ones read as really flat or straight up. So if you were to actually measure that angle between whatever it's facing versus the y-axis, that gives you that angle. So there's one unique angle Here's another unique one. These ones are almost 0. So you can use that as a parameter. Be like, okay, maybe we start to look at it for its sloping conditions. What can we do with that slope information? What would you want to do with the slope of a detention basin when dealing with hydrology? Huh?
It's water retention capability.
Huh? Maybe.
You can tell you how much you can hold before it's still going.
No, like what I'm saying is, how can we, in this other example, we showed how we can change paver sizes or their infiltration rate to allow for water to allow for water to go into the ground. We could also use, so like, is there any correlation between slopes of a surface and stormwater?
Speed,
Speed?
the interval,
What is speed affect?
the volume at the end,
No, think about how is that going to affect the space?
that thing you said was the 30 minutes and it went for an hour.
Well, that's part of it. Like, I'm just trying to think like there's going to be less absorption, and so if there's less absorption, there's going to be more runoff. What's going to happen to that surface material? It's going to erode, right?
Wow.
So you can start to, so another way you can do that is, okay, if it's really steep, so there's erosion. What about, who cares? What happened? What now? So what? You can't really grow vegetation on steep slopes. What do you see in our built environment to address erosion besides vegetation? Retaining walls, right? So maybe you decide to create, the steeper it is, the taller your retention walls are, so they can hold back stuff. These ones can be really interesting. Maybe they even become thicker. And then these ones, either they have nothing or they become thin and short. So you can kind of create this interesting geometric form based off of like the slope. Because I mean, this is a pretty kind of very simple slope, but if you have a very kind of intricate sloping detention basin, you could have your retaining walls respond to the slope by their height, their width, all that kind of fun stuff. And then obviously, like these ones that get really thick, that are holding back a lot of soil versus these thinner ones, what's that going to do? Vegetation, right? So maybe these shallow, thin ones just have some grasses and brushes, and some acacias, stuff that are more kind of tolerant for being submerged in water, versus these thicker ones have a tree and now it's shading this person as they sit. You can start to really see how these things create something cool, and not only are they this interesting responsive geometric form, but what else are they? You get it right, you can leave. What's this semester about? Performative, right? Wow. It's not rocket science, right? But you can create these pretty profound solutions by, like I said, by taking on one issue, you can start to solve these multitude of issues, and they all respond, which is incredible. So.